Good evening, team. Welcome back. I'm Corey, and we're about to get started on day 12 of Advent of Code in Rust. I recorded day 11 and realized I had no audio, so we're skipping day 11 for now, and I'll record a summary video to fill the gap eventually. I also didn't get day 12 solved in this one sitting, but it's long enough I wanted to release it on its own. If you missed any of my other previous days, check out the playlist up top for all my solutions, and don't forget to like and subscribe for more videos. Let's get started. Okay, let's dive right into day 12. Day 12, Hill Climbing Algorithm. You try contacting the elves using your handheld device, but the river you're following must be too low to get a decent signal. You ask the device for a height map of the surrounding area, your puzzle input. The height map shows the local area from above broken into a grid. The elevation of each square of the grid is given a single lowercase letter, where A is the lowest altitude, then B, and so on, up to the highest altitude Z. Also included on the height map are marks for your current position S and the location that should get the best signal E. Your current position S has an elevation A, and the location that should get the best signal has a location Z. You'd like to reach E, but to save energy, you should do it in as few steps as possible. During each step, you could move exactly one square up, down, left, or right. You avoid needing to get out your climbing gear, the elevation of the destination square can be at most one higher than the elevation of your current square. That is, if your current elevation is M, you should step to elevation N, but not to elevation O. This also means that the elevation of the destination square can be much lower than the elevation of your current square. Yep. Here you start in the top left corner. Your goal is near the middle. You could start by moving. Oh, okay, got it. So they're not unique. For some reason, I was thinking they were unique, and I was getting confused. But that doesn't make sense. Okay, so we can go anywhere we want. Okay. Here you start in the top left corner. Your goal is near the middle. You could start by moving down or right, but eventually you'll need to head toward the E at the bottom. From there, you can spiral around to the goal. In the above diagram, the symbols indicate whether the path exits each square moving up. The location that should get the best signal is still E, and A marks unvisited. In the above diagram, the symbols indicate whether the path exits each square moving up. Oh, the path exits. That's weird. Each square. Okay, so you just follow the path, which makes sense visually and is why they did it. But reading it was hard. Okay, so they do a little spirally thing, and then you eventually can get to E. And you're gonna have to touch every letter because that's just how it's gonna work. Okay. What is the fewest steps required to move from your current position to the location that should get the best signal? Okay, so I think this is a prime search problem. So A prime is a way to search through a map and find the best way through it. And I think we can define just like neighbors as things where you can get up. So like A and C won't be neighbors. So like we won't consider them a path. And I think A prime will let us find the path. I bet for like the first bit we could like brute force it, but I don't think we will eventually. But let's start with parsing, and we will get to everything when we get there. But I'm thinking we're gonna A prime this one. Oops. Saw some behind the scenes OBS there. So the first thing we want to do is cargo new 12. I did it again. Let's do this real quick. One more behind the scenes and minimized. There we go. Now I won't do that again. And yes, what is this called? Hill climbing algorithm. That's all we needed. Hill climbing algorithm. It's a lib, and the name is again hill climbing algorithm. Algorithm. I feel like I spelled algorithm. I definitely did. G reset. I know it's G clean dash force directory. There we go. And we do this again, except we spell algorithm right. Awesome. Okay. So now here, let's add it to our workspace. Hill climbing algorithm. No, 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 no. Does it so many times before I can finish typing. Okay, there we go. We now have this, and we have our test that does nothing. Let's delete this. And let's see, part 1 takes an input. It's a string. It gives a U size. I think that's going to be fair. What we output out of here is going to be a number, so it's the shortest amount of steps. Perfect. And then we just to do the whole thing right now. And then, yeah, let's download this. New file, example.input. Paste that in. Go to our here. We're gonna write a test. It's gonna be a function. Example input part 1. Let input equals include string example dot input answer equals part 1 of input cert equals answer 31. I think it was 31. 31. Awesome. Okay, yay. It compiles and completely fails because input's even unused. Awesome. Okay, so we want a, like, what is this, a mountain? This is like a hill climbing algorithm, so like hills. Like, what if we just call it the mountainside? We have a struct, that's the mountainside. And it has hills, which is do we know the size of it? I guess not, right? Because I'm assuming my input's much bigger. Okay. So we definitely don't know the size. So, well, I guess I could make it... No, we're just gonna go with not knowing the size. So we have a vec of what do we want our inside type to be. I think we can just have it be, because this is kind of going to be like a reference. So let's just have it be the character like it's gonna be. Let's actually test something. Let's actually write another test because I want to test something out really quick. And that seems like the best way to do it. Test char order. Debug. Actually, yeah, I can like just debug it out. A is greater than B. Run test. What did I write? I wrote test passed. Do we see? Oh, A greater than B, false. B greater than A. Awesome. But like I can't do off by 1, I bet. Wait, what can I? Can I just add 1 to a B? No. That's fine. I just wanted to figure it out. But I probably can do like A as U8 plus 1 as char. I might need some boop. Maybe not U8. I'm not sure why I picked U8. That feels a little bit smaller than I meant. Like it'll work, but like we can just make it a really big guy. Can't add char. Oh. Can't add. Oh, I see, because this is associating on that side. Oh my gosh, I keep making this worse. Okay. Now only a U8 can be cast as a char. Okay, so I was making the right thing, and then I just messed it up. Yay! Look at that. Casting a U8 to a character to that truncates. Awesome. Okay. But like, is it gonna run? Uh, false. Yep. And I can do change it to equals equals, run it again. True. Awesome. Okay, so U8s and characters are like moderately interchangeable for our purposes, but do we want, like, let's just make a hit struct for it. Like, we talked about it, we went through all that work, and they're just gonna have a height. Oh, that's a character. Should I just make it a U8? Is it gonna make it easier? I think it's just gonna make it easier if I make this a U8. Hills are clone and copy. They're easy to deal with. Nothing wrong with them. Mountainsides are gonna be, yeah, clone, but not copy. Okay, so let's do let mountainside mountainside, which is a mountainside, equal mountainside. Nope, not quite. Colon parse input generate. Okay, so we have our string. We want to break it into lines and break each line into characters. So input dot lines dot map on each line. We want to do line dot characters dot collect dot. These are not characters, so let's now just map this to a map RC to a hill of C as U8. Okay, and then that we can collect. Then we can collect that, and then all of this can be called hills, so that we can just do self hills. Oops. That's characters. Awesome. Okay, so then we get our hill, and then so let's see. Okay, so we already parsed everything out. That was awesome. Make sure that we're working. Run this one. Yep, there we go. Look at that. We have some things. They have numbers. That's awesome. Okay. So now we need to implement an A prime search example. So the idea of A prime basically pseudocode, is that what I want? No, let's just do like let's try the chess wiki. That didn't work. It's not that chess wiki. I just thought maybe it was gonna be there. Okay. Oh, is it called A star? Most people call it A star. I call it A prime. I'm probably wrong. Pronounced A star. Yeah, see? So just wrong. Okay. A star. The idea is that you move through. Oh, is this gonna work? Yeah, so you like move through the options that you have, um, picking the best one based on like how far you've already gone and a heuristic of how far you have left to go. And so yeah, we're gonna work on something like that. I think we're gonna see how much we can do from memory because that sounds a little interesting, but I'm not sure how far we'll get, but that's okay. Okay, so we're parsed. And so another thing that we're gonna need is we're gonna need a struct called coordinate. And it's gonna take in a usize and a usize. And then we're gonna want, so I'm gonna do some helper stuff that I think we're gonna want before we get started. So impl our mountainside, a function called neighbors. Neighbors, yep. Takes in a reference to self and a coordinate. Coordinates are also going to be copy. Drive, oh, yep, definitely debug. and copy clone. Okay, so we have a coordinate and it returns, we probably just want to vec, like we could maybe make it an iterator depending on if we need to do that, but, yeah, I don't know, it sounds fun. Let's make it an impl iterator. Oh, iterator where the item, is a coordinate. The whole, actually no, let's do the to do. So okay, well no, let's do, oh well, if um self dot inbounds, which doesn't exist, c, so if it's not inbounds, um then we return, how do I return an iterator that doesn't do anything? That's interesting. Nope, so that's not gonna work. Interesting. Let's return a vec. I'm not worried about this yet. I don't know if I needed to return an iterator and the types would have been weird. So let's just do this. This just returns a vec. Inbounds doesn't exist, but that's fine. Okay, so now we know it exists. So I guess that's like actually interesting. Should you, I guess I don't really need that edge case because what I'm gonna do is oh, I don't know what I want to do. Okay, so let's say we have a enum for direction and we have up, down, left, right. We impl something for dir. There's a function called all. It returns an array of dirs of length 4 that looks like up, down, left, right. Can you put the, oh man, it doesn't want to do that for me. That's unfortunate. Repeat. Oh, wrong spot. Does it repeat there? Yeah, it repeats if I put it there. Okay. Okay, so then, but we can do something here like dir all dot iter. Okay, so then we can filter, or we can map to c dot in direction of d, which is the directions we have. So we go in every direction. We filter for self, we filter on, now we have a coordinate. We do self dot inbounds is in inbounds. Let's just do inbounds like that. On CO, let's do original. So the C can be C. And then we collect. Okay. Neither of those exist, but we can generate the in direction method. Okay, so we do, if we have, we match on D and we fill the arms. If it's up, we make the coordinate of self dot 0 and self dot 1 y plus 1. I don't really think it matters which order we do our coordinate system as long as we are consistent. But I guess that would make this 0 0. Yeah, that's fine. This can be 0 0. We can go down from that way. Now, but then is up gonna want to be minus to like match what I'm looking at? That might make the most sense, right? Because if I'm gonna parse it that way, and by going to, I mean I already did. Okay, so we take this. The down direction is gonna add. Left and right though still get to be the same way, or like, you know, the normal way. And then this one is get to be self dot 0 plus 1 and self dot 1. Okay, that one looks right. Awesome. So we have indirection, and now we can do inbounds method. So then, if c dot 0 is greater than 0, and c dot 0 is less than, greater than or equal to 0, and c dot 0 is less than height, width. And we don't really need this if, it's just going to be a lot of this. And c dot 1 is greater than or equal to 0, and c dot 1 is less than self dot height. Height is the easier one. A self dot hills got length. This one doesn't need an unwrap, but this one we actually don't know the width since we don't like store it anywhere or anything, and like we totally could, but what we're really just gonna do is go to the first one, but we don't know there's a first one, but like we're gonna just be okay with that. Well, there's a panic there if we don't. Okay, so we're getting pretty close now. Consider dereferencing, sure. Because inbounds is just takes a coordinate, not a reference to a coordinate. But okay, what are we getting at here? Um, what don't you like? Errors. There we go. Absurd extreme comparisons because 0 is the minimum value. Oh, I don't have to check for that. Nice. That the comparison's always true. I forgot we're dealing with, oh, well, actually, I don't know if I want to do that though. I might want to deal with negative numbers just to make things easier so I don't have to check for bounds there. These can be U8s though. It's my coordinate. Where did coordinate go? Where are you, coordinate? Oh, there you are. Let's make these eye sizes. It's just gonna be better. Now, is it mad about them still? Well. As eye size. So right now we have U sizes. Um, and we just want to get them into eye sizes. We don't technically know that they're going to fit because eye sizes have a smaller range, but these are going to be low numbers, so they will fit. Okay, so now we have all the way back up to neighbors. Okay, so now let's start actually just writing the problem because I think that's the right thing to do. So function, I guess we can just do it in part one. No, let's do function count steps. And I guess the other thing that we need to do is figure out where start is. Here it's 0, 0. But I don't know if we, so let's do that first. Well, no, let's do this. We're gonna do it this way. Self, count steps is gonna go to a U size. Okay, so let starting position equals self dot starting position, because there's a function there. We're gonna search for that s character. Okay, so then we have our starting position. So then while well, then let's do let mutable current position. Could have just started with current position, but like, you know, it's fun. Equals starting position. While current position does not equal let target position. That's going to search through and find the other ones. These are going to be coordinates just to help the compiler out while I don't write these methods. It also means it'll help fill it in better when I do tell it to write the methods for me, which is nice. There we go. Okay. Well, current position does not equal target position. We're going to have to make these comparable. Partial equals. Okay, well, this is yeah, okay. To do. Okay, so, and then, like, the other thing that we need is we need an immutable path, which is a hash map, from hash map of coordinate to coordinate. Um, no, it's just a hash map of these things. That's reasonable. Um, isn't it? Oh, it doesn't, we haven't, it doesn't, there we go. Didn't know what a hash map was. So now that should be fine, right? Syntax error, semicolon needed. Does it want hash rocket? Okay, there we go. I was just confused. I don't know why I was getting confused there. Let's implement these before we get much farther, just because we can. And I guess actually what we want to do is search for, and then we take a needle, which is a character. And then we do let needle equal character as u8 because that's just we're using u8s here, and then we do 4 0 dot dot self dot width. All right, let's do height first. For y in, for x in 0 dot dot self dot height. I'm not sure what happened with my double self here. That's not that needle. Um, if so let c equal coordinate at x comma y. If self dot get, well, didn't I do a, oh no, I didn't write something that went into that indexed into it. Okay, cool. Get c, if that equals our needle, then return C. I guess this is gonna have to be an option because I want to return a sum down where I used it. Sum C, or else we have to return a none at the end. Implement this method. Oh, it doesn't even know what to give it here. It gives, oh, I guess it actually should give it a hill. And from our hill, we should do that. Yep. Awesome. Okay, so self dot hills uh, uh x comma y. We should just be able to decompose that. We can. I just have to do it right. Hills at x and then at y, right? Because no yx. Aha! That's gonna save us so much. What's going on here? Can't be indexed by I size. Oh, yeah, those are I sizes. Gonna have to go back and forth, but that's why we have the get method. Okay, so now we can search for the thing. Oh, and that's how we can implement the two starting positions. So this is self dot search for the character S for starting. Yeah. And then what's the unwrap, yeah. We're gonna say we know it's gonna happen. Where's the other one so it can make it for me? And it's basically this though, where this is replaced by an E and there is no to do, obviously. Okay. Now I have starting position, we have target position. Variables in this condition are not mutated. Yep. Okay, so and then we need a to search equals a hash map of coordinate things we need to search, and I think we want like a u size. I think we want them to have a estimation of, I don't think I want it to be a hash map ideally, right? Like I think there's a better data structure, like a heap, binary heap. What does a binary heap look like? A binary heap. I wanted like the docs of a binary heap. Priority queue implemented with a binary heap. This will be a max heap. Yeah. So yeah, I want a max heap of something. Yeah, okay. I've done this with heaps before, but I could just what I was thinking was just use a hash map and like kind of fake it, and maybe we'll start there, but I'm not sure that's the best idea. Um, so then I think what we want to do, we need to do for C in self dot neighbors for starting position. Actually, I think we really do want this to be an impl iterator item equals coordinate. Because I don't think that's gonna be hard. I think it's just gonna be that. Dang it, hidden type for that captures lifetime that does not appear in bounds. Qualify? No. I think what I need to do is for an A plus an A or something like that. No, I'm not in item, but in just the iterator. Dang. There is a way I think to make these lifetime. Wait, can I just do that to make it not be that one? No. Hidden type captures lifetime. Yeah. Click the full diagnostics. What does it want me to do? Oh, okay. So I got halfway. I kind of did this right. Instead of doing that there, this needs a plus, and then we can ignore it. Can't return value referencing temporaries. Oh, well, if I make this a const function, those aren't temporaries anymore. Um, oh, well, that was into iter. There we go. Uh, uh, to force ownership to take. Oh, okay, yeah, we can take ownership of that. That's fine. I don't need it not to. Why is my indentation off? There we go. Okay, so we take our direction, make it into an iter. Does the const function matter there? No, we still want it to be const because we can. And then we map in direction. We filter for the ones that are in bounds. Yeah, because those are our neighbors. Okay. So then for the neighbors from starting position, we do to search. Oh well, actually, so let's do some stuff. So then let estimation. So part of the algorithm for this is to estimate the distance, and we're just going to use Manhattan distance. So we're going to do less estimation equals c dot. Let's do ending or target position dot distance to or Manhattan distance. Let's define it. Manhattan distance to C. And then to search dot push um um C, and then our estimation. This is going to be mutable. Manhattan distance, no method name and Manhattan distance found for struct chord. Yeah, I knew that one. No method push. Yeah, I think both of these are kind of related. I think for this to work, this needs to be hash. And is that all? No. I think maybe it needs to be equal. I don't know. Let's implement this first. Oh, whoa. Ah, undo. Oh my gosh. What's happening here? Undo, undo. Why is there this just random to do in the middle of my code? And why is my undo not getting rid of it? Okay, where were we and what just happened? Um, generate Manhattan distance. A self dot zero dot abs diff of other dot zero plus self dot one dot abs diff other dot one. Here I can just, oh man, I thought I could just get rid of, oh, I see. I size. Oh, this is U size. Remove parentheses. Okay, there we go. Oh, this is not other. Other. Okay, so Manhattan distance is now implemented. Push. What else does this coordinate need? Oh, it doesn't equal. Okay. Hash equal. Does that work yet? Wait, what's going on? Why can't you push? Insert? Yeah, it's insert. What does insert need anyways? When the key and value doesn't say. Can we always do it? Like how many of these? I bet it's just hash. I bet I don't need equals, but I want partial equals. Okay, sorry. Oh no, we might have needed equals. Okay, so um, I don't think I want that. Um, So I guess, yeah, I really do want this to be a different data structure. A hash map doesn't make sense. So like, I think what I want to do is I want to do another struct to search. Wow, this is getting complicated really fast. Coordinate and score, which is just gonna be a U size, I think. And this is gonna be a binary heap of a to search. Um. Yeah, to search needs to be order. Derive, debug, partial equals order. I don't actually want that. I can do all of those, but then I want to impl partial partial order, for to search. And then I just want it to implement everything for me. And I actually just want to do on, oh, uh, that. I just want to partial compare the U sizes. I want to ignore the coordinates. Except I think I actually want to do other dot one and self dot one here. And the reason for that is because it says in binary heap, the docs here that we read a little bit, that this is a max heap and we're going to want a min heap. So we're just going to flip the ordering and it's going to like become a min heap for us. And then now we can just do impl ord for to search, and I don't think this has any methods. This is just marking it. Oh, is there a method? Oh, cool. Partial compare and compare. So this isn't like equals and partial equals, I think. Because I think equals you just do. Yeah, there's not actually anything here. But that's fine. Um, Perfect. Okay, so now it has ord. We can insert it or no. Push. Wait. To search dot, what can we do? We can append to you. We can extend into peak push. Oh, yeah, because we don't have this anymore. We want our to search equals to search of C, comma, estimation. And then we push our TS. Yeah, and then we can do this equals to search dot pop. Take the thing off of our binary heap. So we're going to take the next coordinate by this estimation thingamabobber here. Okay, and then we have our path. Yeah. Okay, so we haven't chosen, or is this considered choosing and we should add something to the path? I don't actually know. If it's in to search, that means we can get to it. And if we can get to it, then it needs to be in the path, except for the first thing. I think to search just needs to do to search dot push a to search of starting position and 0. And then this starts to become the body of this. While current position does not equal target position. Yep. Okay, so then current position, we don't need to add it to search. I don't even think we need this. So then we want for n in self.neighbors of current position. Yep. Okay, so for all the neighbors found, pop, we don't know that's gonna have anything, but we promise we do because we just pushed one. I guess really this could just be this then, right? If I'm popping it off here. Oh, I know what the reason to do that is. Oh wait, no, or if we run out, but I'm fine with assuming that we're not gonna run out. Okay. Current position equals to search, while it doesn't equal the target. Well, current position dot 0 is not equal to the target. For n in neighbors, current position dot 0. Okay. Can't compare these ones now. Variables in the condition are mutated in the loop body. Uh, Variables in the condition are not mutated. Oh yeah, I know. Okay, so for these neighbors, okay, fine. Let's fix that. Current position equals to search dot pop dot unwrap. Okay, so then for all the neighbors, we do path dot insert current position to oh, does this need to be one of these as well? Because we could have found okay, yeah. Okay, so to search, that one actually kind of does want to be a separate struct. They're going to be really similar, but we don't want a to search. We want a path to has a path to has a coordinate and a u size. Yep. Okay. Let's implement all the things on this. Okay. So let's see here. Path to, oh yeah, path dot insert. Oh, so this doesn't go to a coordinate. This goes to a coordinate to a path 2. So close, but not quite the same. Okay, but now we need to insert a path to Does current position want to be a path? Does current position actually want to be a path to? Insert current position. Well, if I make path to copy, um, insert. Oh, current position. Oh, that doesn't help me here. Current position. This can be a to search because it matches that better. Okay, sorry. We insert current position dot 0 to a path 2, where this is our n, and this is current position dot 1 plus 1. Wow, okay. Because neighbors are one step away. There we go. But what you're still very unhappy. Can't borrow path as mutable. Where are we borrowing path as mutable? Oh, insert. Okay, did we just not make it mutable? That's easy. This is like more like paths. It doesn't matter that much, but it's more like paths. Okay, so when we added our neighbors, okay, and then we also do to search dot append. Nope, not append. We just want like push dot push. We push a to search, and then we do our estimation. Well, we do how far we've already gone, which is current. Oh, sorry. We need to search to n with our estimation being current position, how far we've already gone, current position dot 1 plus current position dot 0 dot Manhattan distance to n. Let's extract this. Can we extract this to a let? Probably, but I don't know how to get it to do that. Refactor, extract into variable. And then from here, I can do rename symbol to rename this to distance or dist estimation. Awesome. Okay, so the reason for doing the estimation is also the reason we have the binary heap. It's so that we pull things off in a relatively efficient order. If we didn't, we might have to search through the whole heap to find the thing. This allows us to do it a little bit faster, and there are some edge cases where this is like the worst case, but it's a pretty good. It works pretty well in practice. Okay, so and then once we insert, yeah, okay, that might be what we need to do. So then from our paths, we want to let a actual path. Let's make this mutable because I think that's going to be the easiest way to do this. Equals. Right now it's just a vec. And let's just make it of coordinates. Okay, so I guess we want to do like let mutable current coordinate equals, oh, we probably already have starting position. Okay, so then we want to do while current does not equal target position. We do the same loop again, basically, but differently. Let next equal paths dot get current. And then what is the next thing? Next, we actually might just want the 0. Is this just gonna be let current? No, we're not quite there. Okay, sorry. This is let next. Let's not grab the 0 out of it yet. This wants to be a borrow. That's easy enough. And then so now we do actual path dot push. I think let's do current here. And then actually no, let's push the next thing. And let's have starting start there. So let's push next this get we're gonna say is always gonna work. And then next here is a path to, which I think I want the first thing out of there. And then current equals next. Except I also want the dot zero, which means really next here could just be our dot zero. That's what I tried to do earlier, but I wasn't confident about it. Okay, so that should construct our path. And then this is really just actual path dot length is our answer, but like I want to debug a reference to actual path for sure, because I'm not super confident in the answer. Like I'm confident in the answer, but I'm not super confident in the answer. Let's see though. Yeah, okay. Would have been really cool if that worked on our first try, but not super surprising. We just panicked at an unwrap though on line 68. Um, self.search for, oh, we just don't have a capital E. Isn't that what we are supposed to be finding? Ooh, okay. That one's interesting. Um, search for, okay, so let's just debug out the mountain like I had at one point. I just removed it. Let's make sure we're actually seeing that. Debug out, well, okay, let's do another thing then. Let's debug out what B as a U8 is. Awesome. What's wrong with you? Oh, reference it. Run this test. Okay. 69. Hill. Yeah, Hill 69. Okay, so let's go and look through our to search. Actually, let's write a test for just this. Function to search end example. Open let target equal ms.target assert equals target and coordinate 0 0. Not the right answer, but an answer. Needs the test macro. Run the test. Okay. Definitely called unwrap on none value. Okay, that makes sense because I didn't do anything special here. And it was panicking before. But search for oh. Well, actually that probably doesn't mean that probably wasn't the bug at all because they're probably the same. It might not be true though. But let's find out. Oh, 5-2. Yeah, okay, I found it now. And does a 5-2 match what I think it should be? 0 1 2 3 4 5 0 1 2. Yep. Replace 0. Replace 0. Let's just take that out and put it there. And this is just ms starting position. Test. Test. Okay, now still panicking here. Unwrapped on line 142. Now what's this one? Okay, so while paths.get. Okay, yeah. Debug up, but that means we are done. We finished the thing. That's pretty awesome. Oh, is this because of what I did here, but I didn't put anything in paths of how to get here? Yeah, that's definitely what happened. I know what the problem is though. This is just gonna tell me 0 0. Oh, 7-0. That's not what I expected. Because we started with 0-0, and then we eventually hit 7-0, and then we unwrapped something on 144. Oh, interesting. So there's no path to the current here, even though actual path push paths.get. Yeah, so the paths here are set from you start somewhere and you go somewhere else. And if we start at starting position and we get the neighbors from that, we go from starting position to all of these positions. Yeah, that makes sense. So I think we should just get all of paths every time. Oof, that's gonna be a lot. Let's just debug out paths on its own up here, and we can do current in there. That'll be much better. But our paths, okay, so but it's we don't have a 7-0. 022061. We don't have a 07 apparently. How could we have gotten something without it being in here? How did that happen? That means we don't go to anything. Wait a sec. What am I looping over here? Oh, 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 when I insert a path, I don't need to do that. I need to do something different. If so let existing path equal paths dot get current position dot zero. Okay, so right now what's happening is every time we find a path, we stamp over it in this paths array, but that's not what we want to do. I'm actually not sure if this is the problem. Yeah, I think it is the problem. Okay, so we try to get the thing here, and then if there's something in existing path, we look at it. And then if do we already have the estimation? Let's do that first. Let's refactor. Oh man, oh I missed the capital into a variable called. Oh man, it doesn't even do that for me. If we call this estimation, we do that up here. If existing path dot estimation, let's do let new path equals this let, and then if it doesn't, so if there is nothing here, this is this that we had over here. But if the existing path exists, and well, what is existing path? It's a path 2. Dot 1 is less than the estimation. Then we use these existing. Now let's do equal to. I don't know. It seems like I don't want to change this out as often. Else, we use the estimation. Estimation is not the right thing. Here we do this again. Whoa. Nope, path 2. Okay. Copy. Sometimes using the Vim key bindings is harder. And then here we insert a new path. Okay. Existing path, that's a path 2. Okay, so this needs to be cloned. And it just wants to be dereferenced. Okay, there we go. So let's see if that works. I like that these are still in here. Oops, that's gonna pass because that was unrelated at this point. Oh, lots of debugging. Doesn't look like we're actually moving though. But we're printing on line 156. So if we're printing on line 156, that means we think we made it through to the bottom. Okay, so if existing path is less than the estimation. Oh, does the estimation already have the +1? Yeah. Wait a second. That's not right. Path 2. When I insert to path 2, I do current plus estimation. So this I need a Manhattan distance in here. Oh wait, this is Manhattan distance. Current plus Manhattan is the estimation. Okay, never mind. That I think is right. Well, it's broken, so I guess something's still wrong. Um, Wait a sec. What? I thought it just looped infinitely a second ago. This infant? No, that wouldn't make any sense. Oh, okay. I see. So it's the difference between greater than and greater than equals here. If I do 1, I end up in this. But if I do a different one, I end up in a different spot. Is that what's happening here? Here. If I say they're allowed to be equals, I infinite loop. Yeah, okay. That feels like a base condition mess up or something though. Like, does this just want to be 1? No, that doesn't make any sense. First of all, why can't I like, oh, because I'm recording. We're gonna quit VS Code and open it back up. Felt like it was having a few problems there. Okay. Let's go down and run this test again. Okay, so this is infinite looping. There we go. And that's because it has an equals here in this. This doesn't have an equals, we just get the wrong answer. Or we panic because we don't have a place to go. Oh, wait. Paths. How does my paths work? But I'm wondering if I'm doing it backwards. I need a path from. Path from. Um, and then this is gonna be a path from. Rename symbol path from. Um, Path from. Okay, but now what are you mad about? Can't find paths. Paths. Oh, that's fair. This could just be called paths, and then I could rename it to path from. Paths from. Okay. These are paths from. So, if you want to insert something here, the path from is the current position dot zero. This is current position dot zero. Yep. Okay. So the from here is current position 0, and new path. That's fine. This is n and new path is current position 0 if it's less than. And then here, where we go from current, we actually do this as target. You start at target here. Probably don't need that. Paths from dot get, and then let's actually just do actual path dot reverse here. Uh, sure, and let's debug it out. Okay. Now we at least got now the actual path we got is just 5.2. We're just done. That's easy though, because I have this set to, I changed it to start at target and end. I didn't change it to end anywhere different. We got 2. Okay, so we go from 0, 0 to 5, 2, and we're just done. Love that. That's pretty awesome. I'm assuming we have some path froms that are a little more interesting than that. But obviously we just always go from 0. That's just where we were always from. Okay. That doesn't seem right, so let's check out this logic here. Um, if, okay, so for neighbors, there's an existing path, from, paths from for the neighbor. If there's an existing path for the neighbor, we do an estimation. Yep. Now, man, we get a different path though, at least. What's the path? Do I see the path? Actual path is what I meant to print out. Oh no, I am printing out actual path. Did I see it? Or is it just not as far? Am I too far down? Actual path. 0 to 1, 0, then to 2, 0, 3, 0, 3, 1. 0, 1, 2, 3. Wait, 0. Oh yeah, see, so this path isn't very right. Oh, I didn't actually do this problem at all. So now I think my A star is working. But what I didn't do for neighbors is I have to filter out ones you can't get to. Neighbors. Filter the ones that aren't in bounds and filter for C dot self dot neighbors of original. So let height equals self dot get original. Okay, so we get the height, self dot height plus 1 is greater than or equal to self dot get x. This is just height, not self dot. Right, height. Oh, height is a hill. Let's just do dot 0 dot 0. I did this backwards. Ah. What do you mean? Okay, I'm not sure why I have to do that, but it's fine if it works. Probably because I'm returning this iterator here. Okay, so we filter for where the height plus 1 is greater than or equal to the other one. Yep, those are the path. That's the path you can move in. Because I just found the wrong path, and I found a really short path, and it's probably just because without the rule, that was the shortest path. So now what's the problem? Now we called unwrap on none on line 150. We ran out of things to search. Paths from. Okay, let's see if we can figure that one out. Oh, paths from is empty. Why is that happening? To current position does not equal. Wait a sec. What? But to search. Oh no, paths from. Yeah, but paths from is empty. Or am I just printing out the wrong thing? Paths from was empty. Interesting. So we never made it into here? Because that doesn't make sense either. Unless there's no neighbors. Unless there were just no neighbors at all. Yep. Okay. So like I could do a test here for example starting position has neighbors. target dot uh um neighbors of starting position dot length. I'm not sure if it's one or two, but uh oh, assert equals count. Run this and we get the answer of, yeah, there aren't any in that, but if we look at the internet, there should be, yeah, you should have two. Okay, so why are there no neighbors? It's obviously that last filter I just added, and the answer here is two. It's like the ones right next to it. Yeah, we'll just go with two at the moment. Or do I want to do the yeah, let's just write this. Let neighbors. Nope, I don't want to write this right now. I'd have to make it a vec and test those things, and it's fine. Oh, I could just compare the sets. That's probably the answer, but it is again fine. Um, okay, but why aren't you working is the answer. So neighbors have if height. So if we get the height of where we're starting, the neighbors are places we can get to. We can get to it if we add one to our height, and that is greater than or equal to the height of the other place. Okay, so that like seems pretty right to me. Height, comma, self dot get x dot 0. Get debug all of these out for me. And we're gonna run the small test. The small test says that we looked at the coordinate 0, 1. We have a height 83. That has a height 97. Oh, okay. That, I forgot about that. Um, when I do the get for height comparison reasons, or I guess maybe when I go to parse, should I just replace it? No, I need to write something on here that's a function height that takes in a self, or actually I could write this on hill. Hill, impl, hill has a function called height on self. Match self. If you are starting as a U8, that maps to A as a U8. I was hoping that we could just do that. I was hoping I could just do some as's there. Height goes to a U8, yeah. And end goes to a Z, and then X goes to X. Anything else you just pass through. Self.0 actually. That'll make more sense for that. Yeah, so I don't know what that is. Can I put this in parentheses to make it happen first? Yeah, see, I don't know how to get this besides just doing something silly, like going down to this test and doing debug. I could just open up a table somewhere, but this seems easier. I'm not sure easier, but as U8 and then ending as U8. Let's just get the magic numbers that we're gonna need. So star, oh man, I have to fix that up there first. Um, Okay. Debug. Wait, do I not see that debug? Starting has neighbors. Yeah, so it should be. Yeah, there we go. Wait, like, oh, there it is. 83 and 69. 83 and 69. 83 and 69. There we go. Okay. What does it want me to do? Use a byte literal. Use a byte literal. Oh my gosh, wait. So, oh wow, that's just so cool. Okay. Because I can just have it be a byte literal. So does that mean I can do byte literal for starting and a byte literal for ending, except I did my literal characters there wrong? That's pretty awesome. Okay, so now I want to use height instead of get, or no, I just want to get height from it. In this one spot where we're doing things for height, um, neighbors. That's where height matters. Uh, height. Okay. Does this work now? Yeah, it does. Um, so we got a lot of debugs. Let's remove some debugs so it runs faster. Oh no, that's an end one. I like that at the end. Okay. Fact that it's still running doesn't give me a ton of confidence. Because that doesn't seem like it should be continuing to run forever. And we already said if existing path is less than estimation. Um, and this has nothing to do with the things or estimation for this one. I feel like I'm missing a Manhattan distance. Or here's distance estimation for to search. Okay, so this is an estimation. This is actual cost. Actual cost is current position. Yep, that makes more sense. So if the existing path is less than our actual cost, we use the existing path. And this is paths from, so end to new path from, is current. This is actual cost. If we do a new one, yeah, I don't see what the bug is, and it feels like we just have an infinite loop. I guess I just want to panic here and say we done. I want to see where we're infinite looping. I want to see if we get to there. Nope, we do not. Okay. So we are do something over here. So debug out the current position at the end. Let's see what we see. Did that? Is there another infinite loop inside of this? There's no way neighbors is infinite looping, is there? Let's do that. Okay, current position is changing. I just didn't get it the first time. I think the thing is I might not have canceled it and I had created a weird state that we had gotten into. Okay. Where's the end? There's the end. Okay, so current position. We're getting some current position debugs. Let's see what those look like. Oh, this is still there. Did I get rid of it? I got rid of it on accident. Because I wanted to stop it from building. There we go. Okay, so Two search like 2321, 2321. Okay, so we keep going back and forth between some of them that all have 10. Okay, so we go back and forth between a few points. Um, current, so then new path. So I guess distance estimation should really be. Oh, wait a sec. In this case, do I just want to continue? And then, yeah. So we don't want to update the to search again with a new thing if we didn't actually find a better way to get there. Because we've already done that before with a different one. We don't want to override it. Now we at least got an answer. That's much better than what we had before. Let's go to all of our debugs. That's the only one that I want to keep. Okay. Except actual path isn't very helpful right now. Oh no, but actual path is the coordinates. Path from is the thing that's not very helpful right now. I just want to see the path. Okay. 001011. Okay. 001011. And then 21, 21, 22, 22, 32, 22, 23, 0120123. Yep. 23, and then 2434, 243444. Yep, 4454, 5464, and then we go 7401234567. Yep, 01234. Okay, yeah, definitely wasn't even. I missed that earlier. That's good. Okay, so then we go all the way up to 7. Oh wait, we made it to 70. Oh yeah, 70. And then 6543, 6543, and then we go this way again. 3 1 2 3, 1 2 3, and then 1 2, 1 2, and then 1, and then 1. So we just stopped. Why did we stop at 5 2 there? 0 1 2 3 4 5 0 1 2. Oh, 5 2 is the end. Oh, I'm not supposed to go in this last one. 5 3 to 5 2. 0 1 2 3 4 5 0 1 2 x to z. We're not supposed to go from x to z. X, Y, Z. Okay, so there is that point when I'm comparing those things. Except, wait a second. Oh yeah, 5 2 is the target. I get there from 5. Wait a sec. 5 3. Yep, let me count this out again. 5 3. 0 1 2 3 4 5 0 1 2 3. We get there from the V. And we go up to 2. How is that one? Oh wait, no, 5 2. Yeah, because 5 2 is the end spot. 5 2 0 1 2. So like from here, instead of going up and around more, we just go up from this V to the Z. Okay, so did I mess up those characters in that thing up there? There's a really good chance my characters are just wrong. Nope. A to Z. Start to end. And we are gonna add 1 to height to get the other thing is greater than equal to, I guess I want height here though. Ah, is that a bug? That's probably the bug. Because it got the actual character value for E there, potentially. 32. Okay, there we go. Because it's counting this one, which I don't want it to. Okay, but that means the way to fix it, one way to fix it, not sure the best way, is to do actual path.pop. Actually, no, let's leave that. I want it on there, but we're just gonna subtract 1 from this. Okay. It's passing. Let's get rid of some debugs. Oh, didn't end up needing that one. Didn't need that. No more debugs. Okay. All of our tests are passing. And let's grab our my input. I hope this pays off for part 2, where this is just trivial for us now that we have everything implemented. But I guess we're gonna find out. Um, my input part 1. My input not gonna equal 31, but that's okay. Uh-oh. We can definitely run it in debug mode, but or in release mode, but I still feel like it shouldn't take that long. Let's just make sure this is still returning. Yep, that one still worked nicely. Um, that feels more like a bug than anything. I think it's actually taking that long. Okay, so we'll spend a few minutes debugging, or we might do another break here in a minute. Let's see. Let's debug out our current position. Let's just see what it looks like. We've got to be looping somewhere. Oh, now it doesn't compile. This thing probably doesn't implement copy that I thought would. There we go. Because I needed to debug out the reference instead. Okay, so what are we looking at here? 411 to 627. Oh yeah, because we're just looking at next stops at 14. Okay, yeah, sure. But why would it be infinite looping? Like we shouldn't have infinite options of 14. There's gotta be a missing +1 or something here. Okay, so actual cost to get to the neighbor is existing path, our actual cost. Yep. So the new path, so new path dot one is, yeah. So oh, wait a second. Oh wait, no, but we have that continue in here now. Because we only set the path if it's better. If existing path is better, if it's equal to or better, we don't even keep searching with our distance estimation. Yeah, because we should have already had a to search with the better distance estimation done from the other thing. So we only need to keep going if this. Okay, so then actual cost, this needs to be actual cost plus the Manhattan distance estimation. We were in a we didn't add bug here where this was not +1ing. Okay, does it work with the example still? Yep. Let's get rid of a debug again. Does it work with my input? Shouldn't have gotten rid of that so soon. Add the debug back in. My input. Same-ish thing. We're just now we changed coordinates. Now it's on 27 distance that we're running into issues on. So to search is the actual cost. So, but this really could be described as new path dot one, but that's the same thing because the only time we use new path and don't continue is when actual cost is that. This though really could be just using existing path. Does that break anything? Because that feels right as well. No, see, then we infinite loop in this version if this isn't a continue. Um, Interesting. But when we continue here, because I guess we just keep adding things to search in that case. Um, so the distance estimation is the actual cost to get here plus the Manhattan distance of. Oh, no, 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 no. It's the Manhattan distance of n to target. We have to actually estimate the path to the target. We just got lucky and we're filling the entire space in that one, I bet. Let's get rid of our debugs, because now this is at least going up. So maybe it's just that our debugs are making us run slowly. We could also run them in release on the command line. Let's try that, but I guess I'm not that confident. Cargo test release. Nope. Example part 1 is still taking a while. Okay. I keep thinking we're gonna have found it, but we don't. Okay. Keep taking it out too early. Like, it is counting up in distances, which is interesting, right? But it's obviously. Oh, there we go. Did it hit a loop again? No. But it does seem to be hitting things where it gets the same number for quite a while. And now is it? Now it seems like it's pretty much looping between a few of them. Um, okay, let's look at our algorithm again. So we compare if there was an existing path and it was a better path, we just don't, then we're like, great, we didn't find a good path to this spot, and we just give up. Um, Less than or equal to. Yeah, that passes that one. And oh my gosh, it passes that. It gives me an answer, 441. Okay. Is that gonna be our answer? There. Oh no, it's not quite right. Your answer is too high. If you're stuck, make sure you're using the full input data. There are also some general tips. You guessed 441. So it's too high. Oh no. Okay. Um, I guess the thing I want to try 440 just to check it. Nope. Oh, I gave it to you recently. I have 42 seconds left. But I don't think that's going to be the case because I have this one working over here with 31, and this one is telling me that the answer should be 441, 441. 14, 13, 12. Okay. You guess 440, still too high. Yeah, okay, so it's just not the right answer. But we do still get the right answer for the small one, which is annoying. Okay, so if the existing path is existing path dot one, yep, is less than or equal to our actual cost of getting there, we continue. And this is just +1 because we got to it from 1 from the neighbor. We know we can get to the neighbor because that's part of our neighbor thing. So then path from current position dot 0, actual cost. We insert the new path. And we search it. We add it to search if it's not already there. I actually don't know what would happen. They'd be different estimations even if they were the same n. But that's what this is for. That's why we compare it over here with the Manhattan distance to target. Yeah, that looks right. And then once we do that, we find a new current position by just taking the best one to search for. And then this is just, we just go backwards. So we start at the end, because we have paths from, so we have paths from the current. This really could be like renamed to previous. Actual path dot push previous, current dot previous, and then we reverse it to make the list make sense. We return that right there. Yeah. We could look at it for just a second, but I don't think I'm gonna be able to just figure out the right answer or anything for the big one. So we end on 9120 and like 1, 2, 3. Like I just don't want to count over 9120, but like that's where the end marker is, I bet. Like yeah, 9221. Yep, exactly. So 9120 is definitely the right spot. You could only get to it from 9220, 9220. 9121. Oh wait, so we got there from like the wrong way, which is like makes sense, but like the only way to get there is from this one, which should be 9220, not 9121. Do I have another dot zero where I need a height? That would be a good one to have. Search for dot zero. There's gonna be way too many dot zeros. Dot zero. Inbounds doesn't care about that. Search for. Nope. Yeah, nope. Search for doesn't. It's not that one. Nope, 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 no. No. It's none of these ones. It would be dot zero on my hill. I want to go to every reference of a hill, but that's like feels like it could be a lot. Yeah, and these are all those hill. So I need the hill dot zero where I want height. So where am I calling height right now? Let's find code paths that do that. So if you have an S or an E, map it to an A and a Z. Yeah, okay. Height is original dot height, and then we do get dot height for this one. Yep, that one looks like the right usage. Self dot height here, that's on a different thing. That's a different method. That's a different method. Yeah, that's the only usage. The only time we compare heights is when we're looking at neighbors, which makes sense. That's the only time we need to compare heights. If we do this, everything's just gonna break because now we can't go up mountains. Failed. It almost definitely failed on. We ran out of things to search. Yep, we ran out of things to search. If we say you can't go up Amount in it all, we want to say you can only go up one thing at a time. But that's not what happens. We go up two things at a time here, and we don't want to. Because we go from 9120, we get there from 9121, which is 91, wait, 9221. Yeah, because we subtract 2, so it's 9120. But then 91, 92, 20, 21, and then this one is 21. So the one that's 21 wants to be 22. So this one, yeah, so we're going from Y up instead of following the Y. Oh, actually, it's too high though. So that doesn't make any sense though. Why would it make the answer too high? It means we're doing things we don't need to do. If existing path is less than or equal to our actual cost. Yeah, if it's equal to, we also don't need to keep going. It's only if our new path is better should we keep going. Okay, let's take a quick gander at some A star pseudocode. Actually, let's not do that. Let's look at, so I haven't mentioned it yet on this, but I compete in a thing called Battlesnake, which has a lot of these algorithmy things. And one of the things I think I have hidden somewhere is an A prime. Okay, A prime inner is where our logic's going to be. Okay, so we have paths from, yep, which is from a position type to an option. So this one doesn't keep track of that there, but that's okay. To search and known score. Okay, so to search, we add our starting point with no cost. Known scores, we say start as 0, and paths from, we just add it to make something else happy later, I think. Okay, so while we can pull things off of search, if the target contains the thing, we can just A prime, we can return it. We're just returning our entire structures, I think. Paths from, yeah, we just return paths from and the target. But if we're not returning, this is my wild condition, really. We do for in neighbors, we get a distance, yep. Let tentative equal, we get the thing, and we get a score from it, and we add the neighbor distance. This unwraps wrong for this code. Or we might want to unwrap and not unwrap or. We know we're always going to have a score, and max doesn't make sense because we're going to add to it. But anyways, tentative. So then we do for neighbors filter where the neighbor isn't a target and is not a snake body. That's fine. If the tentative is less than, yeah, not less than or equal to. If tentative is less than known score dot get. Yeah, so like if there is a known score that's better, we don't do anything. Known score insert paths from insert to search. This looks really, really similar to what I have. So why is this not working? Like it's not the same, right? But existing path, if there is an existing path and the existing path is better than our actual cost, we don't do anything. It's only in the other case, either the existing path is worse or there is no existing path, that we say that we can get to our neighbor from this with actual path. Our distance estimation is our actual cost plus the Manhattan distance. To search equals tentative plus heuristic. Yep. Tentative plus heuristic. Where tentative is the thing that goes in known score. Yep. That looks super right. Okay. We might call this a day again and pick this back up tomorrow because we've been going for a while and I'm not seeing where the issue might be. There's a path that we're not taking that we should be, and I don't know what the answer is. I'm not seeing it. Um, you can go from X till the width, and you can go from Y till the height. The height is just getting the first things, but that just means that these have to be implemented correctly. My indirection thing, there it is. So from self, if you want to go up, you from the second thing, which is Y, you minus one, downs plus one. Yeah, left, right, those are right, assuming that X and Y want to be those directions. So for inbounds, the first thing is X, which is the width. The second thing is Y for the height. We filter for things that are greater than or equal to, yeah, because you can jump down, you can only climb up one thing. Yeah. Mm-hmm. Yeah. I'm not seeing our issue here. Y is to height, X is to width. And those ones are right anyways. Um we get Y out of the first thing, X out of the second thing. That just helps all of our positions make sense. 0 to 0, 1 to 1. Partial is 0 to this. This is this to this. Um, oh, but it's the other way around. I could do this as partial. It's fine. No, it doesn't make sense because I'm just putting it down to the next layer. So never mind. Never mind. Never mind. I still don't think I have a good answer at what's happening. So I think we are gonna wrap up, or I'm gonna wrap up, and you'll see me again in, 10 seconds for you. And I will be back, take a break, and hopefully we can solve this next time. Thanks for joining. See you in a sec. Bye.